Hello and welcome to the course Optical Character Recognition, OCR in Python. My name is Jones Granatier and I will teach all the lectures in the course. As you can see in this image, the idea of OCR is to send an image to an algorithm that will transcribe the image to text. It is very common when you use a scanner to get the page of a book and you need to get the image in textual formats and then use it in word processing software, such as the Microsoft Word. Another common application is the registration of credit cards in apps, in which you only take a picture of the cards and the system reads all the data automatically. It is not necessary to enter the data manually. This course is about this subject and we will use the Python programming language. Now let's see the main topics that will be covered. First, you will learn how to work with OCR using Tesseract. This tool is supported by Google and it is one of the most used in commercial applications. You can see this Google Colab file, which means that all implementations will be made step by step using Google Colab, so it will be easy to follow the course since it won't be necessary to install all the software in your own machine. We can see the topics of this first part we will cover since the installation until searching for specific information. For example, you can see this example of a bank statement, and if we want, we can extract just specific information, as the date in this example. In topic number 2, you will learn techniques for pre-processing images, because when you work with OCR, the quality of the image is very important to extract the texts correctly. So, sometimes some pre-processing are needed in order to improve image quality. You can see this other Google Colab file with all the topics that will be covered in this section. The thresholding, we can see, for example, that it is possible to improve the quality in this particular image. There is lighting differences, and the OCR algorithms may have some difficulties to extract the texts correctly. We will also work with color inversion, with resizing, and some morphological operations, such as erosion, dilation, opening, and closing. We can remove noises using these techniques. And also, we will have a specific section about noise removal, and you are going to learn about the average blur, the Gaussian blur, median blur, and also the bilateral filter. All of these techniques will be used in the next lectures. First, we will improve image quality and then send the image to OCR. In the next topic, you will learn how to work with OCR using YIST, which is an architecture to detect texts. So there are two steps. First is the detection of the text, and then the conversion from text to image, which is OCR. And this tool is very interesting when working with natural scenarios, when there is no control of the environment. You can see this example in the other Google Colab file, where there is a picture of a natural scene. The goal is to detect and recognize this text here in the cup and see that there are a lot of background information. Here you can see the list of topics that will be implemented step by step in this section. Then you are going to train a custom OCR from scratch. And at this point of the course, it is important that you know the basic intuition about artificial neural networks and convolutional neural networks, since we will build a custom convolutional neural network in order to train our custom model to detect digits and letters. And at the end of the course, there are two sections about this subject. The first one about the classic artificial neural networks, and the second one about the convolutional neural networks. I encourage you to watch both sections in case you don't know the basic intuition about these topics. There are two Google Colab files that we will implement in this section. The first one is to train the neural network, and you can see all the topics that will be implemented step by step. We will use two datasets. The first one is the MNIST, which has images from the digits from 0 to 9, and we will also use the Kaggle AZ dataset, which is composed by the letters from A to Z. The goal will be to join both datasets to train our custom OCR. And after training the neural network, we will be able to apply text recognition. We will use a lot of pre-processing techniques to read the image and extract the texts, and the goal will be to make the predictions. We can see here, for example, that letter T was detected here with a confidence of 99%, and the goal is to send an image to our neural network and it will be able to make the predictions. In the next topic, you are going to learn how to work with EasyOCR, which is another library, and it has good results for natural scenarios. We can see the Google Colab here, first with the example of the cup. We can send more complex images, and it is able to extract the letters and also the numbers. We will perform some tests with other languages, such as French and Chinese here. We will also explore how to improve the visualizations using background information. We can see these results of a touristic plate in the Portuguese language. Then we will use OCR applied to videos. You can see this short video of only 4 seconds, and the goal is to process each one of the frames and extract the information, as you can see here. And at the end, to recap all the content that is covered in the first sections, we will implement step by step 3 projects. The first one is to search for specific terms in images. We will recognize the text of images and save to TXT file so you can use it later. We will also apply some natural language processing techniques such as the word clouds to see the most frequent terms and also the extraction of named entities. For example, you can extract the name of people, the name of companies, locations, and so on. Then, we will apply text recognition in images, and we can see some results here. For example, if you want to search for specific information in the images. Also, in this paper, it is possible to find the terms that you are looking for. This is the first project. The idea of the second project is to simulate a scanner equipment when you take a picture of the page of a book and you need to extract the text. You can see this picture of an invoice, and it is not in the vertical position. And if you send this image to OCR, it may have some difficulty in understanding the text. For this reason, in this case study, we will use a technique called perspective transformation, where we will have as a result the image in the vertical. And you will also learn how to improve image quality, for example, increasing brightness and the contrast. You can see here the results, apply adaptive thresholding, and so on. And finally, the last project is very interesting, which is related to license plate reading. There are a lot of commercial applications that use these techniques. You will learn a lot of pre-processing techniques in order to extract the location where the plate is in the image. We can see here some of the pre-processing. We are detecting the contours to get only this part of the image. Then we get only the letters and the numbers in order to have this result here. After that, we can send for text recognition. We can see some examples here that we are going to implement step by step. This is the plates. Then we can extract only this part of the image. Here is the result. See that we could correctly get each one of the texts, and then we can print the result at the end. As you could see, there are a lot of contents that you are going to learn step by step in this course. We hope we enjoyed this course and have a lot of ideas of how to use OCR in your own projects. See you next time!